In this last video for chapter 12, I'm going to talk specifically about geometric sequences and series, and we're going to be looking at sequences and series where I multiply to get my next term. So let's look at this problem here. It says write a formula for the general term of the geometric sequence. And here's the geometric sequence. Negative 1/7, 1/56, negative 1 over 448, and then 1 over 3,584. So I'm noticing that to get from negative 1/7 to 1 over 56, I would need to multiply by negative 1/8. Okay. Same thing to get to the next term, and same thing to get to the next term, multiplying by negative 1/8 each time. That tells me something important. It tells me that my constant ratio r is negative 1/8. Okay? I'm going to use that information to write a rule. So to write a rule for a geometric sequence, I'm going to use the formula a sub n equals a sub 1 times r to the n minus 1 power. Okay, a sub 1 is my first term, which is negative 1/7. So I'm going to substitute a sub 1 for negative 1/7. I'll put that in parentheses. Okay. R is my constant ratio, and I already figured out that R is negative 1/8. N is my general term number. So there we go. Negative 1/7 times negative 1/8 to the n minus 1 power. There's my general rule. Let's do another one. Find the sum of the geometric series. And my series is the sum of 4 times 2i, or 2 to the I power, from I equals 1 to 5. So what I'm going to do is I'm going to first notice that this is a finite geometric series because it ends with the fifth term. Okay? I could plug in 1, plug in 2, plug in 3, plug in 4, plug in 5 to my rule and then add them all together. But I have a formula that might make my life a little bit easier. So for the first n terms of a geometric series, a finite geometric series, I can use this rule here. And the rule is that the sum of the first n terms is the first term times 1 minus the constant ratio to the n power over 1 minus the constant ratio. Okay. So let's find the first term. Let's find a sub 1. Let's do a little side work. A sub 1 is when I plug 1 into my rule. So 4 times 2 to the first power. That gives me 8. Good start. Constant ratio. That's easy. It's going to be 2. Why? Because if I find a sub 2, I would have 4 times 2 squared, which is 16. And I know the thing that I would multiply by to get from 8 to 16 is 2. So it tells me the thing I need to multiply by to get from one term to the next is 2. So 2 to the n power over 1 minus 2. Oh, oops. I know what the n power is. N is going to be this number right here, 5. So 2 to the 5th. Okay. Let's figure out what this is. This is going to be 8 times 1 minus 248. Seems about right. I could check it. Alright, next up. Find the sum of the infinite geometric series. This time I have an infinite geometric series. And I know that because the dot dot dot, it goes on forever. I have this formula I'm going to use, and I can only use this formula if the absolute value of r is less than 1. So let's just double check this right here. To get from 2 to 1/2, I would multiply by 1/4. To get from 1/2 to 1/8, I would multiply by 1/4. So it looks like my constant ratio, r, is 1/4. 1/4, or the absolute value of 1/4, is less than 1, so I'm good. I can use this formula. If I couldn't use this formula, I would have to say that the sum doesn't exist. So I'm going to use this formula. Okay. A sub 1, that's my first term. Check it out. It's 2. So I get 2 over 1 minus my constant ratio. That is 1/4. Okay. 1 minus 1/4. Well, I could think of that as 4/4 minus 1/4. That's just 3/4. So let's just write that as 3/4. 1 whole minus 1/4, 3/4. Okay. Now I have to think of this as 2 divided by 3/4, which gives me 2 times 4/3, which equals 8/3. So the sum is 8/3, the sum of this series.